Okay, so this problem is on Newton's second law. And in this problem I have a block that has a mass of 7 kilograms. It's pushed down a plane that's tilted at 30 degrees below the horizontal with an initial speed of 11 meters per second. And the question's asking, what is the magnitude of the acceleration if the coefficient between the block and the plane is 0.19? And so free body diagram down here, the block would be here and it would be going this way. So the frictional force is this way, the gravity is down, and the normal force is perpendicular to the x-axis. So I went ahead and wrote down what is given: the mass, the angle theta, the coefficient of friction, and we're trying to find the acceleration, the magnitude of the acceleration. So for this, you'd start with the sum of the forces in the x direction, which would be negative frictional force in the x, plus and the plus is because the mass times gravity in the x direction is going in the positive, so it's plus mg sine of the angle, and the y components would be in y in the y direction. In is positive and the mg is negative, it goes down, and multiply that times the cosine of it to find this right here. And to get n by itself, you would do some algebra to figure it out. N equals mg cosine of theta. And then from there you would combine these two and you'd get this equation here: coefficient times the mass times gravity times cosine of theta plus mg sine theta, and that would all equal the mass times acceleration. Divide by mass. Masses will cancel, so you'd end with coefficient times gravity times cosine plus gravity times sine, and fill in your numbers from here down here. And I plugged it in the calculator and got 6.5 meters per second was the magnitude of the acceleration of the block going down.